Hello students. So today we're going to be doing a video lesson, but it should hopefully work as well as when I'm in class, except that you won't be able to get me off on some tangent. Anyway, before we start, make sure that you have a pen or pencil and the packet from the substitute, which should look exactly like the screen you're seeing right now. Just as a spoiler, I just wanted to show you that there's a formula that we're going to be that's going to be very important to us, that we're going to be using quite a bit this year, and the formula looks like this. It says H equals, I'll put it up here. H is equal to negative B divided by 2A. So can you commit to memory that H equals negative B over 2A, and later on I'll show you what that means and why it's going to be so helpful and important to us. So hold on to that for now, and in a little bit hopefully you'll see that formula and where it came from and why it's going to be so useful to us. Alright, so as you can see from the title, characteristics of quadratic functions. The homework you did yesterday should have been mostly a review of transformations of quadratic, so if you understood chapter 1 well, hopefully you're at a good place for this one. So a couple things that we talked about yesterday, in our previous class I should say, is this axis of symmetry. And if you look at this graph right here, the axis of symmetry is the line, the vertical line that goes right through the vertex. And if you remember, that was a new term that we had yesterday, describing that point either on the very bottom of a parabola, or if it's flipped, on the very top of the parabola. We will often use the letters H, K to represent the coordinates of the vertex. And actually we'll use HK later on in pre-calculus for some of you. So anyway, notice too that, and we'll get back to this in a little bit, is that the axis of symmetry is written as x equals h. In other words, x equals the h value. So for instance, what if h was, I'll say 3, say the vertex had a coordinates of 3, 2. If it had the coordinates of 3, 2, this value 3, this would be 3 here on the x-axis. And for that reason, we would call that equation, sorry about that, we'd call this equation, this line, this red line, x equals 3. So that's what they mean by that. I know sometimes you guys get a little upset about symbols and things like that. And so a concrete example of this is that the vertex is at 3, 2, that the axis of symmetry is just x equals 3. If the axis of symmetry was, say the vertex was something like 5, 2, well then in that case we would have an axis of symmetry at x equals 5. So whatever the x value is of the vertex is also the value that we associate with the axis of symmetry. So we're going to see all these things a little bit later. So if they're not totally clear to you right now, we'll see. They should hopefully be in a bit. So the axis of symmetry is the line that divides a parabola into mirror images and passes through the vertex. Because of the vertex f of x equals ax minus h squared plus k is hk, the axis of symmetry is the line x equals h. So previously we've used a transformation to graph quadratic functions in vertex form, but we never used that term in vertex form till yesterday, or our previous class. You can also use the axis of symmetry and the vertex to graph the quadratic functions written in vertex form. So later on we're going to see that. So first thing we're going to do is we've certainly been graphing. Can't get this thing on here. We've been using parent functions and the transformation of points to graph, and as you can likely know, that's an awful lot of work. So what we're going to do is try to see if we can streamline our ability to graph a quadratic, and what we're going to do is use the axis of symmetry to do that. So a couple things that we need to do first is we need to pull from this from this equation the value of the vertex. And if you remember that the value of the vertex is if you go up to this formula up here, it's the opposite of what's inside the parentheses. I think we know that. And so we're going to get -3, 4 as the vertex. So going to our graph and go to -3 and up 4. And you should have a point right here. And now what I'm going to do is, to help me later on, I'm just going to draw the axis of symmetry. And the axis of symmetry is going to go right through the vertex. It is a line. And this line is going to be called, can you guess what it is? X equals what? Yes, -3. Now we're going to find 2 points. And what the easiest points to find are the ones that will be either to the left of the vertex or to the right of the vertex. So 2 points to the left of the vertex again is at 3 up here. And so 1 point that we can find will be let's go ahead and see if we can figure out what the point for -2 is, and also for -1. So let's do that first. So I'm going to say f of -2 is equal to -2 times -2 plus 3 squared plus 4. This is going to be equal to -2. -2 plus 3 is 1. 1 squared is just 1. So almost there. And so there we finally get f of -2 is equal to 2. So that's a point. Remember that when we use function notation, that's the x value, that's the y value. So we can graph that immediately. So it's going to be -2 up 2. Now let's go ahead and find the other point. The other point I said was going to be the -1. And again, I'm trying to find points that are either immediately to the left or the right of the vertex on the x-axis. So in this case, we go f of -1. Sorry, it's so messy, but anyway, f of -1 is going to be -2 times -1 plus 3 squared plus 4. This is equal to -2. 2 squared plus 4. 2 squared is 4. It's gonna. I don't want you guys to make. Some of you guys make some weird mistakes around here, so I'll go ahead and use as many steps as I can. But right now it's going to be -8 plus 4. I'm just going to settle at -4. So f of -1 is going to be -4. So go -1, and then we're going to go down 4, and there's another point. So in the old days, I had you guys calculate. We would be transforming 5 points, but I just had you do 2. Why did I do 2? Is because the axis of symmetry is splitting this parabola directly in half, which means that if this point here is 1 to the right of the vertex, then there should be another point 1 to the left of the vertex. Similarly, if we go down to the point, this bottom point here, the bottommost point, it's two boxes away from the axis of symmetry. So there should be another point 2 boxes to the other side of that axis of symmetry. So this way, by using axis of symmetry, what we can do is forego having to calculate those other 2 points. So not a great looking parabola the way I'm doing that, but I wonder if I could make it any better. Probably not, but all right. I don't think it's going to work. All right. Anyway, I just don't like the way my parabola looks. So, the heck with it. Let me just go ahead and finish. All right. Well, something like that. Hopefully you can do a little bit better. This should not be a point. And anyway, so you get the idea. So you're going to be, hopefully you're going to get a chance to graph some of these things. But the idea, again, is just, to review. What we did is we first found the vertex. This was our first step here. Our second step was to locate 2 points near to the right of the vertex, or at least the x values to immediately to the right and left of the vertex. And then what I did is I plugged in those 2 points, all right, graphing those points. And then part 3, use symmetry. Symmetry. Oh, golly Moses, I'm so sorry. To plot the other 2 points. Yeah, sorry about the messy. It's I have to keep my hand off the screen, or otherwise this doesn't work. So it looks a little bit messy, but be patient with me. Now what I want to talk about is something a little bit different, and this is something that you may be aware of from previous courses, and that is that whenever we have an equation, I'll give you an example, say something like f of x equals 2x squared minus 3x plus 5, just random numbers there. Whenever we graph something like this, we'll notice that we also get a parabola. So what this is also a quadratic, but it is in what is called standard form. And in standard form, we typically call whatever value is in the front. Think of it like y equals mx plus b. You know how we use m and b as values on the line. In a similar way, for vertex form, we'll call the number in front of the x squared term a. The number in front of in front of the x term is going to be called b. And the constant number all by itself over here we call c. So we can rewrite the quadratic f of x, the standard form. So basically, so the basic shape of standard form is that some number times x squared plus some number b times x plus c. So this is y equals mx plus b in a sense for the parabolas. Now this next piece you might want to speed up because you don't have to remember it, but what I'm going to do is I'm going to transform the general formula for vertex form of a parabola. So that general formula is a x minus h squared plus k. So this is the way we shape the this is the formula of the parabola that we've been using for a while, where h and k is the vertex. So what I'm going to do is I'm going to expand everything. I'm going to take a, and I'm going to multiply x minus h times x minus h, and plus k. Continuing, I got a. If I expand this, I'm going to expand it a little quicker than you might be able to, but it's x times x is x squared. And then I got x times negative h for negative hxh, and then, I'm sorry, negative hx, and doesn't matter what order. And then I got the inside. So I'm going to end up with negative 2hx and plus h squared plus k. All right, you guys are already tired of this already, I'm sure. Let me move this up a little bit further, give me more space. So distribute the a, I get ax squared minus 2ahx plus ah squared plus k. And then what I'm going to do is I'm going to group the x terms. So, well, actually, there's only one x term. So what I'm going to do is take the rewrite it in a way that hopefully will make a little bit more sense. We got ax squared minus 2ahx plus, I'm going to put in parentheses, the ah squared plus k. So I'm pretty sure I've lost a few of you, but what I want to do is compare this f of x equation here on the bottom to the one on the top. And basically I'm going to notice that this a and this a are the same. So they stretch or shrink will always be in front of the x squared term. The piece that I really am interested in here is this one. The value that comes before the x, which we call b, is going to be called negative 2ah. So that doesn't look like anything amazingly profound, but check this out. If I divide both sides by negative 2a, I get a formula for h. h equals negative b over 2a. So what that says is that even if I get a formula that is in standard form, I can still find h, the value, the x value of the vertex, and then from that I can plug that value in and find the y value of the vertex. So say we get a quadratic, it's not in points, it's not in vertex form, I will still have the ability to graph it pretty quickly. So h equals negative b over 2a, and that was the spoiler I gave you at the beginning of the day, and this is something that I want you to memorize. It also might be worth mentioning that we can also find the value, the value c in the quadratic. We can use this formula here to find the constant value of the function, but we're going to hold off. We're going to hold off on that. In other words, we can get the k value for that from this function from once we know what the h value is. But let me move on. I just want you, for our purposes though, this is the only formula that's really that we're gonna be using a lot. Okay, next page. So on the second page, you'll see this is the question that we just addressed, was quadratic written in standard form. And again, the chief takeaway of that is that we expanded this equation using all the letters and everything else that drive people crazy. You don't have to remember how I finally did this, but I do wish you would. I would like you to remember that the final outcome was that we created a formula for finding the x value of the vertex, and it's negative b over what, people? 2a. Okay, and so this gives us some tools for graphing very quickly that we've never used before. So let me show you how we're going to use those. But before we do that, there's one other thing that's going to help us graph, or can be very helpful in graphing, and that's to know what the y-intercept is, or how to find the y-intercept. And quite simply, the y-intercept happens if you look at a graph, an xy graph like this. You will notice that any value that's on the y-axis has a 0 value for x. So the idea is, if we're trying to find the y-intercept, all we really need to do is to plug in the value 0 for x, and then find out what that y value is when x is 0. So I'll give you a quick example. If I have an equation, here's a linear equation, 2x plus 3. If I plug in a 0 for the x, what do I get? I get y equals 3. That's our y-intercept, and we know that because that's slope y-intercept form. Well, what happens when we have a quadratic? When we have a quadratic, it's pretty much just as easy. So let me erase this. And so if I have a quadratic and I set x equal to 0, almost always we're going to find that the y-intercept is the constant. So here it is. We go y equals 3x squared minus 25x plus 3. So plug in 0 here, plug in a 0 here, and what do we get? Well, these terms cancel out, and we're left with the constant term. So typically with a quadratic, the y-intercept is just going to be that last value, that constant term at the end that remains once I put 0 in for x. So hold on to that thought. So the y-intercept here as a point is going to be 0, 3. All right. So we're going to hold on to that thought because that's going to be a useful tool for us when we start graphing in a moment. So let me erase. And we'll move to the next. I think we're going to move to the next page where we have an opportunity to do some graphing. So next we go through here. Sorry about that. Here it is. So y-intercept again. Here's a quick review of what I just said. Let's do two. I'll do 2 equations, and you're going to tell me the y-intercept of them. So y equals negative 36x squared minus 12x plus 5. What is the y-intercept here? Well, it's going to be plug in 0 for x. The x values cancel, and I'm left with the point 0, 5. All right, pretty easy. Y equals, if it seemed easy, you got it. 293x squared, doesn't matter, right? Minus, or plus 95x minus 6. Well, what's going to be the y-intercept here? The y-intercept here is going to be 0, negative 6. Plug in 0 for the x values, and we end up with a negative 6. So we'll use that in our graph, our next graph. So let's go ahead and let me show you. So here's something new for us. This is in standard form, this equation, and what I'm going to do is we're going to graph it in standard form. You look at it the way it is, and you're going to, typically you should just go, whoa, but we have the tools. So let's do a couple things first. Let's go ahead and find the vertex. Let me show you how we do that. So first thing we're going to do is we're going to identify these terms. This is the A of the quadratic. This is the B. And the 1 is the value of C. So what we're going to do to find the vertex is we're going to use that formula H equals negative B over 2A. Okay, now we're going to learn all our new use all our new tricks to be able to quickly graph some quadratics. So you'll notice that on this page, which I don't feel like giving enough space for, you might want to use some scrap paper for this because it's just some of the work we're going to do is going to take up some space. But what we're going to do is we have 4 graphs to make, and then I have one little piece to talk about after this, and we'll be done for the day. But what we need to do is to graph this, and there's the things that we need to do to graph. Quite simply, we need to find the vertex, and let me get a black vertex, and then we need 2 points. And we're going to get the 2 points by just plugging in points either to the left or the right of the vertex. So the closer they are to the vertex, the easier they are to calculate. Notice that for questions 1 and 2, we're already in vertex form, and for 3 and 4, we're in standard form. So what I'll do is let me do number 2, and I'll leave you the easier one to do after that. So let's go ahead and take a look at number 2. So step 1, find the vertex. Well, this one's in vertex form. So hopefully you'll be fortunate enough to figure out that the vertex in this case is going to be, can you guys guess it? Drum roll please. It's going to be 2, 5. Now I apologize already because some of the graphs the graph paper that I use for you guys is going to be short by a few boxes in a few of these graphs. But let me go ahead and graph 2, 5. And we know this graph is going to go up, way out of reach of my graph in a moment. But what I need is 2 points to the left or right. Typically, I think if you move toward the y-axis, you get the smaller numbers. So I'm suggesting that we go, if the vertex is at 2, right? So we could use the number 1. We could plug in 1, and we can plug in 0. We plug in 1 and 0, we can get 2 points. So so we got G of 1 will be 2 times 1 minus 2 squared plus 5. This equals 2 times negative 1 squared plus 5. Negative 1 squared is just 1. Times 2 is 2. Plus the 5 will give us 7. So G of 1 equals 7, and then that neat feature of function notation, I can go right to the point from there. So one of the points is going to be 1, 7, which is right up here at the edge of the graph. And now I need one more point, G of 0. Now G of 0 is going to be a larger number. So it's going to be 0 minus 2 squared plus 5, which gives me 2 times negative 2 squared, which is 4. Take a moment, make sure that makes sense to you. 4 plus 5, it's going to be, 2 times 4 is 8, plus 5 will be 13. And just as I predicted, it's way off the graph. So I calculated it should be 7, 8, 9, 10, 11, 12, 13, somewhere way a heck of there. Let's go ahead and ignore that. My fault. But let's go ahead and use the axis of symmetry. The axis of symmetry in this case, the line that goes vertically through the vertex is going to be called x equals 2. And what we can do is use symmetry to plot this point. So we got 1, 7. So that means that there must be a point 3, 7. There's also another point way the hay up here that I don't want you to have to worry about. So anyway, the parabola is going to be opening up, and just to get to another, whenever we have a parabola opening up, the vertex is called a minimum. I'm going to be talking about that in a moment. When the vertex is, when the parabola faces down, the vertex is on the top, so they call it a maximum. That ends up having significance in calculus later on, and actually some pretty cool algebra problems too. So that's a minimum. Let's go to number 1 there. All right, now that's the one I would like you to do. And if it looks a little weird to find the vertex, let me just remind you that we can also call this, we can also add 1 here. And, no, not 1, I'm sorry, we can add 0, right? There's nothing there, but if I put +0 there, it might be clearer what the vertex is. So I'd like you to pause this, pause the video right now. Take a moment and see if you can graph this. Again, I apologize when the graph moves off the paper that I use, but give it a try. So pause now. Okay, here we go. I have, let me show you what I did. First of all, the vertex, hopefully you got -1, 0. And let me go take a weird colored pen. So you got the vertex is -1, 0. So you drew in the vertex in the graph. There's 2, I chose 2 points to the right. So from -1, you go 0, 1. So I'm going to calculate f of 0 here and f of 1 up here. And I end up with 0, -3, and 1, -12. Again, my graph is, I apologize for the graph, but just go ahead and do it with the 3 points for now. And this is the graph I got. The axis of symmetry is at x equals -1, the vertical line through -1. And in keeping with what we were talking about before, in this graph with the parabola upside down, we would call that a maximum, and that's because it's at the top of the graph, as opposed to the one we had before where it was the bottom of the graph. So we call it, if it's on if the vertex is on the bottom, it's a minimum. If it's on the top, it's called a maximum. So anyway, let's go to 2 more graphs. I'm going to do, now these are a little bit different, and this is where we have to invoke that -b over 2a. So remember that, h equals -b over 2a. Let me pick up the right. Okay. Okay, so here we go. So again, just remember h equals -b over 2a. So I'm going to identify a as -2, b is -8, and c is 1. We don't need to. We won't be using c in this case. So let me find the vertex first. That's my first goal always. So h equals -b, which is going to be +8 over 2 times -2, which is the a value. So this is 8 over -4, which means our x value of the vertex is -2. So now that I know the x value of the vertex, I need to find the y value. I do that by plugging the -2 into the formula. P of -2 equals -2 times -2 squared minus 8 times -2 plus 1. All right, and that's going to give me -2 times 4 minus 8 times 2 is going to be +16 plus 1. -8 plus 16 is 8 plus 1 is, oh, I am way off the graph again. All right, so 8, 9, it's going to be 9, just by a little bit. So, and the next, so that's going to be my vertex. My vertex now is -2, 9. -2, and up 9 is, oh goodness, let me see if I can move this a little bit. I guess I can't, but anyway, maybe I'll just use a different color pen. So, so my vertex is at -2, 9, 7, 8, 9. It's going to be right up here. See my blue dot? This is terrible. Anyway, that's my vertex. My next 2 points should be a little bit nicer because this is a downward parabola because of this negative sign on the top. So I need 2 points to the left. So I'm already at -2. So I'm going to go -1 and I'm going to go 0. So plugging in -1 and 0, I get P of -1. P p of negative 1 equals negative 2 times negative 1 squared minus 8 times negative 1 plus 1. And so that gives me negative 1 squared is 1. So this is just comes down to negative 2 plus 8 plus 1. And so I'm at 7. So p of negative 1 is equal to 7. That's 1 point. And now what I'm going to do is I'm going to plug in the value 0. P of 0. Well, P of 0, believe it or not, is equal to 1. I did that very quickly. Why? Because all those other terms just drop out. So anyway, even though my vertex is in outer space, I can graph these points. So I got negative 1, 7, and 0, 1. I have an axis of symmetry at x equals negative 2. And I just use this axis of symmetry to find the points on the other side of the ones that I graphed. And there I am. So this is my parabola. Now what I'm going to ask you to do is graph the parabola over here. Once you've done that, you're going to be pretty much home free for the homework. So let's go ahead and I'll pause. You see if you can figure out how to graph it. If you are, you're a champion. You're awesome, and then you can stop and move on to the homework. So pause right now and try to do this one, and I'll come back in a minute. Remember, get the vertex first, and then 2 points. Use the axis of symmetry to reflect them. Done. Okay, so let's go ahead and check your work. If you have a parabola that looks roughly like what I have up there, you're in good shape. So let's first find the vertex. Let me use my other colored pen to go over this with you. So we're going to find h first, and negative b over 2a becomes negative 1. We take the negative 1, we plug it into the formula. We get h of negative 1 equals negative 2. Therefore, here is our vertex. Negative 1, negative 2. Now that we have our vertex, we can graph it. And we're going to go try to find two x values to the right or to the left of the axis of symmetry. So let's go to 0, x equals 0, and x equals 1. So moving back up here, I'm going to calculate h of 0 and h of 1. H of 0 is pretty simple. I plug in 0 and I just get a negative 1. Everything drops out. I plug in I find h of 1. H of 1 becomes 1, 2. And finally, a graph that fits. So here's our 2 points, are 1, 2, and 0, negative 1. So these are the 3 points that we need: the vertex, 1, 2, 0, 1, and the axis of symmetry lets us find the other 2 points, here and here. And then we just fill in the dots. So that should do it for today, guys. I know that was pretty long, and if you needed to play any of that back, go ahead and do that. But this is where we're headed. This is actually what we're looking at in summary. Is just kind of an easy way to very quickly graph these things. The first two times you do this, it will take a long time and take a little bit of patience on your part. But in the end, you will get a good understanding of what's going on with these quadratics. So that's going to be all for now, and the other parts of this assignment will be done on Monday. So you'll have another video then, and make sure you have some headphones for that, or Monday, the next day, I should say. Okay. Well, anyway, at this point, if you don't understand anything, please go back and review it. But if you feel relatively comfortable right now, why don't you go ahead to the homework and keep this work available, because you should have the same work at least in your hand on your sheet, so you can use it for reference. Okay. Anyway, good. You guys have a great day. Good luck with the homework, and see you when I'm back.